So welcome to today's video lecture on history of microbiology. So in which we'll be studying about two great scientists called Edward Jenner and Louis Pasteur. So let's get started. Edward Jenner, so his period was from 1749 to 1823. Okay, and Edward Jenner was born on 17th May 1749 in England. So yes, he was born in England, so on 17th May 1749. And Edward Jenner is widely recognized as father of immunology. So yes, we call him as father of immunology. So because of the contributions and discoveries which he has made in this field. He was an English physician and scientist. In 1770, aged 21, Jenner became trainee in surgery and anatomy under surgeon John Hunter and others at St. George's Hospital, London. So yes, he was a physician and a scientist. Okay. And in 1770, when he was 21 years old, so he was getting trained to become a surgeon. Okay. So under a famous doctor and a surgeon named John Hunter, so who was in St. George's Hospital, London. Fine. And then in Jenner's time, smallpox was a highly contagious and deadly disease caused by variola virus, was one of the greatest killers in human history. So yes, during his period, no, so there was most contagious and dreadful disease which was called as smallpox. Okay, and it was taking lives of hundreds and hundreds of people during those time. Okay, so in the 20th century alone, smallpox had 300 million victims. So just imagine, so just in 20th century, so it had about 300 million victims. So it was the greatest killers in the human history. Fine. Then the mortality rate of the virus was about 30%, although it was higher in infants up to 90%. So yes, so here mortality rate means death rate. So death rate of the virus was about 30%. So 30% means out of 100% who's infected with the virus, 30 people used to die. Okay, and this was higher in infants, that is in children, so which was up to 90%. That is out of 100 children who was infected, 90 children used to die. The virus was readily transmitted from human via aerosol droplets from coughing and sneezing like most viruses. So yes, the route of transmission was through aerosol droplets from coughing and sneezing. Okay, so when a person coughs or sneezes, the virus would get transmitted into the air, and the other person, healthy person, when he inhales this virus, he used to get the disease. So this was the method of transmission. Then coming to the symptoms, initial symptoms resemble the flu, including high fever, fatigue, headache, and backache. So this was the initial symptoms. It was just like a flu. So where the person used to get high fever, he used to feel tired, and he used to get headache and backache. Okay, so after the symptoms, all skin characteristics used to come up. Like a characteristic rash follows, progressing from flat red spots to pustules that eventually scab off and fall off, potentially leaving scars. So yes, so after this initial symptoms, no, so rash used to develop throughout the body. Okay, followed by that red spots used to develop, and this red spots used to become pustules. Pustules are pus filled. Okay, and this pustules used to eventually scab out, and they used to fall, and they used to leave scars on the body. Okay, and this used to get affected throughout the body, hands, legs, abdomen region, face, throughout the body. So these rashes, pustules and red spots used to develop, used to scab off, and they used to leave scars. So this was the symptoms of the disease. Then the only means of combating smallpox was a primitive form of vaccination called variolation or inoculation. So that is intentionally infecting a healthy person with the matter taken from a patient with a mild attack of the disease. So yes, so in that time, that is in the beginning, what people used to do to overcome smallpox was by following a method which was called as variolation or inoculation. Okay, so in this technique, a small amount of matter was collected from the pustules of the person who was suffering from smallpox but with a mild attack of the disease. Okay, so here matter was nothing but fluid was drained from the pustules of the person, and so this matter was intentionally infected to a healthy person. So by doing this, the body of the healthy person used to fight against the disease and it used to build up immunity against the disease. So hence people followed this technique called variolation or inoculation. Okay, and when all this was happening, that is when smallpox was taking lives of several people, and several other people, when they were following variolation or inoculation, Edward Jenner notices something unique in his surroundings. Okay, so what was it was? Edward Jenner, in his dealing with smallpox, he had noticed that milking girls at local farms often developed a benign form of the disease called cowpox, which seemed to render them immune to smallpox. So, yes, what he notices was that during his period, so the cattle used to get infected with a disease which was called as cowpox. Okay, so and this cowpox was a viral disease which was affecting cattle, especially cows, and it could be transmitted to humans usually through contact. Okay, so and this was the disease similar to smallpox, so but it was milder disease than smallpox. Okay, and it was not dreadful, and the people used to get cured very soon. Okay, and so the symptoms were a little similar to smallpox. Here also the cow used to get the pustules and red spots and all, and when the human touches that, he also used to get pustules and the red spots and all on his hand or on his body. Okay, and so what Edward Jenner noticed was that the milking girls who was infected with cowpox was immune to smallpox and they never used to get smallpox. Okay, so this was the greatest observations made by Edward Jenner. Okay, so why this was happening was because we now know that cowpox virus belongs to the same family as smallpox, and as such the two viruses offer cross protection, although cowpox leads to a very mild infections in humans. Okay, so why this was happening was because cowpox virus and smallpox virus belong to the same family. Okay, that was pox viridae. So and the milking girls who had already got cowpox was immune to the virus, and this offered cross protection against smallpox. So this was happening there. But so during that time, people exactly didn't know what was happening, and so they didn't know that cowpox virus and smallpox virus belong to the same family. So, but they used to follow the procedure to overcome smallpox. Okay, so with all this observation, so he started making a small research. So, in which in May 1796, Jenner found a young dairy maid, Sarah Nelms, who had fresh cowpox lesions on her hands. Using matter from Sarah's lesions, he inoculated an 8-year-old boy, James Phipps, who never had smallpox. So, yes, so what he will do was in 1796, so he found a dairy maid called as Sarah Nelms. So she was infected with cowpox and she had fresh cowpox lesions on her hands. Okay, so what Edward Jenner will do? So he will take the matter from this cowpox lesions of Sarah Nelms and he will intentionally infect it to the 8-year-old boy who was called as James Phipps. Okay, so you can see in the picture. So this James Phipps never had smallpox. Fine. So after this doing this, what happened? Phipps became ill over the course of next 9 days, but was well on 10th. So after intentionally infecting with cowpox virus, he would become ill and he would get cowpox and he would suffer with the disease for about 9 days. Then on the 10th day he would become good, he would become well and fine. Then on July 1st, Jenner inoculated the boy with a smallpox matter. No disease developed. Protection was complete. Okay. So then after this, on July 1st, what Jenner will do? He will intentionally infect the boy with a smallpox matter. Okay. And surprisingly, so this boy will not get smallpox and he was completely protected. Okay, so and this was the greatest discovery during that time. So thus he was the first person who successfully introduced vaccination to prevent smallpox. So thus he became successful and he was the first person to introduce vaccination to prevent smallpox. The term vaccination is derived from the Latin word vacca, meaning cow, reflecting the source of the protective material. So yes, so here in the term vaccination, vacca means it's nothing but cow. So because he was using lesions from cowpox virus, okay, to get immunity to smallpox, he called it as vaccination. Fine. So this work is said to have saved more lives than any other man. So yes, so and what happened was people started following this technique and this had saved many people. Okay, so it is told that it has saved more lives than any other man. So because it was the dreadful disease, it was taking lives of billions of people, and so this discovery made people to survive. Okay, then in 1798, Jenner, having added further cases, published a book entitled An Inquiry into the Causes and Effects of the Variola Vaccine, in which he described the protective effect of cowpox against smallpox. Okay. Then in 1798, he will actually write a book so entitled An, An Inquiry and the Causes and Effects of Variola Vaccine. Okay, so in his book, so he had described the protective effect of cowpox against smallpox. So how we can use cowpox lesions, how can we use the matter from cowpox to become immune to smallpox. Okay, so this was about Edward Jenner. So next we'll study about another great scientist, Louis Pasteur. His period was from 1822 to 1895. Louis Pasteur was a French chemist, biologist and a microbiologist, best known for his groundbreaking work in vaccination, fermentation, pasteurization. His discoveries revolutionized medicine and public health. So yes, he was a trained chemist, he was a biologist and a microbiologist. Okay, so he's very well known for works in vaccination. So that is, he had created vaccines for several diseases, and he's known for fermentation and pasteurization. So we'll get to know about it further. So and his discoveries also revolutionized medicine and public health. He was born on December 27th, 1822 in France. So yes, he was born in France on December 27th, 1822. Okay. An average student, Pasteur was skilled at drawing and painting. He earned his Bachelor of Arts degree in 1840 and Bachelor of Science degree in 1842 and a doctorate in 1847. So yes, he was average in studies, so but he loved drawing and painting. Okay, and so he got his Bachelor of Arts degree in 1840, Bachelor of Science degree in 1842 and a doctorate in 1847. So this was his educational background, and he has discovered and he has made a lot of contributions. So we'll study all his discoveries and contributions one by one. So starting with it, Pasteur discovered that tartaric acid crystals, though seemingly identical, could exist in two forms that were mirror images of each other and rotated polarized light in opposite direction. Okay, so now what is this tartaric acid? So this tartaric acid is nothing but a white crystalline organic acid. Okay, so that occurs naturally in many fruits and particularly it occurs in grapes. Okay, so the problem with tartaric acid was that tartaric acid derived from natural sources rotated polarized light. Okay, So as I told, so they are mostly found in nature, that is mostly in grapes, and so this tartaric acid actually rotated the polarized light. Okay, so and the same tartaric acid can be chemically also synthesized. So but this chemically synthesized version of tartaric acid did not rotate. Okay, so but they had the same chemical composition, they showed the same reactions, but this polarized light used to not rotate the chemically synthesized tartaric acid. Okay, scientists didn't know why, and this was the problem. So and this problem was actually solved by Louis Pasteur. So and he was the one who told that tartaric acid exhibits in two forms. So they are called as mirror images of each other, and so they rotated the polarized light in opposite directions. That is, they showed two directions of rotations. Okay. Pasteur observed that tartaric acid crystals, when dissolved, could rotate the plane of polarized light. Some crystals rotated it to right, dextrorotatory, while others rotated it to left. Okay, and he was the one who found that the crystals rotated in two different directions. So that was dextrorotatory and levorotatory. So dextrorotatory means the rotation towards right side, and levorotatory means rotation towards left side. Okay, and he thus solved the puzzle of tartaric acid. Okay, and the next contribution was the soaring of wine and beer was a major economic problem in France. Pasteur was asked to help to the local breweries where beer had turned bad. Pasteur looked at some droplets of bad beer through a microscope and observed that the beer contained small rod-shaped bacteria instead of round yeast cells. So yes, so and then actually soaring of this wine and beer was a major problem. Okay, so during those time, and especially in France, wine and beer was used majorly. Okay, so and the problem was they used to turn sour. So after storing it for some period of time, they used to become sour. So and the sour beer and wine cannot be consumed, and they used to be discarded. Okay, so this problem was asked to be solved by Louis Pasteur. Okay, what he did was he brought the wine, so which was bad, which was sour, and he observed them under his microscope. So what he observed was he saw a small rod-shaped bacteria instead of a round yeast cells. That means there was a growth of bacteria in the soured wine. Okay, and after studying, his studies showed that leaving cells yeast are responsible for forming alcohol from sugar and contaminating microorganisms make the fermentation sour. And finally he concluded that so these microorganisms along with the yeast will convert the sugar in the wine to alcohol. So since it's converting sugar to alcohol, the wine or the beer is becoming sour here. Okay, so this was actually discovered by Louis Pasteur. Then Pasteur also demonstrated to wine industry that if wine is gently heated to 60 degrees Celsius for a short time, the growth of harmful bacteria is prevented and the wine does not go sour in bottles and barrels. So and apart from this, he also discovered a method through which you can prevent the souring. Okay, so he demonstrated that if you heat the wine to 60 degrees Celsius for a short period of time, okay, so and then if you store harmful microorganisms, so bacteria will not grow, and so the wine and beer would not become sour. Okay, so this was also demonstrated by Pasteur, and Pasteur then extended this to other problems such as souring of the milk. He proposed heating the milk to a higher temperature and pressure before bottling. The process is now widespread use and is called pasteurization. Okay, and he applied the same principle for souring of milk as well. Okay, he also told that milk, when it is heated to a very high temperature and pressure, so they also will not become sore. Okay, so by heating, so harmful microorganisms will not grow, and as a result soring will not happen and alcohol will not be produced. So this was actually discovered by Louis Pasteur, and this method is called as pasteurization, and pasteurization is followed till date. Okay, so for the milk products, before bottling or before packaging, so we do a method called as pasteurization. So that is, we heat the milk. Okay, so and then after killing microorganisms, after undergoing pasteurization, the milk will be bottled or packed. Okay, so this was one of the greatest contributions given by Louis Pasteur. Okay, and then Louis Pasteur is widely credited with developing the germ theory of disease, which proposes that infectious diseases are caused by microorganisms entering the body. So, and further, he will also give a theory which is called as germ theory of disease, in which he tells that infectious diseases are caused by microorganisms. That is, microorganisms can cause diseases, and they can be infected from one person to another person, and when they enter inside the body, it causes disease. Okay, so this was given by Louis Pasteur, and it was called as germ theory of disease. Okay, and then in 1865 rescued the silk industry from pebrine or pepper disease, a disease of silkworms caused by protozoan. Okay, so this was actually a disease which was affecting silkworm industries. Okay, so the silkworm having pebrine are covered in brown dots and are unable to spin thread. So okay, so when silkworms are infected with this pebrine disease, no, so what symptoms they can see was irregular hatching of eggs was there, and then uneven growth of larvae used to happen, and so they used to lose their appetite. Okay, and more than everything, a brown spots used to develop on the larvae, and they were unable to spin the thread. Okay, so this was the major symptoms which was caused to silkworms. So, and this was also solved by Louis Pasteur. So he developed methods to prevent these diseases by identifying and isolating healthy silkworm eggs, promoting hygiene in silkworms farms, and understanding the role of microorganism in disease transmission. Okay, so this was the method of prevention which was given by Louis Pasteur. Okay, so what he did was, so first he actually identified that the disease is caused by a microscopic parasite. Okay, and he also discovered that it can be transmitted by moth to egg. Okay, and through contact with infected silkworms. So what he did was, so he took this silkworms or moths and he observed them under his microscope. So when he saw the parasite in them, no, so he actually destroyed them. Okay, so because if that particular moth is there, it has a capacity to infect others also. Okay, so he destroyed all the moths which were carrying the parasite, and he also maintained cleanliness, that is hygiene, in the silkworm farms. So by this the silkworm disease, that is pebrine, was prevented, and by this he also showed the role of microorganisms in causing disease transmission. Okay, so this was work done by Louis Pasteur for silkworm industries. Then next was, Pasteur is renowned for his groundbreaking work in developing vaccines for various diseases, including chicken, cholera, anthrax, and rabies. Okay, yes, he also discovered vaccines for chicken, cholera, anthrax, and rabies. Okay, so chicken cholera, Pasteur developed the first laboratory produced vaccine by attenuating the bacteria responsible for the disease. He discovered that injecting weakened bacteria into chickens provided immunity against subsequent infection. Okay. Then uh, he also discovered vaccine for chicken cholera. So chicken cholera was also called as fowl cholera. So and so it usually used to have outbreaks in wet and cold weather. Okay, and it was a bacterial disease. So and The symptoms included the respiratory rate, that is increased respiratory rate, and mucoidal discharge from the mouth, and then localized swelling, and in acute cases the chicken may result in sudden death also. Okay, so this was the symptoms and about chicken cholera. So Pasteur was the first person who discovered vaccine for it by attenuating the bacteria. So meaning of attenuation is weakening the bacteria. Okay, so he weakened the bacteria and he injected them to these chickens. So how they weakened this bacteria? So it was by repeated passage into a non-host environment or by genetic modifications. Okay, so these bacteria were weakened and this weakened bacteria used to be injected to the chicken. So, and this used to provide immunity against the infection. So thus he discovered the vaccine for chicken cholera. And next was anthrax. Pasteur developed a vaccine for anthrax, a disease that primarily affects livestock but can also affect humans. So this vaccine was successfully used in sheep, goats and cows. Okay, and then he also will discover vaccine for anthrax. Okay, so this anthrax was actually a very serious infectious disease caused by bacterium Bacillus anthracis. It is caused by Bacillus anthracis. So primarily it affects animals like cattle, sheep and goats. So but it can be transmitted to humans by contact with the infected animals. Okay, and here also the symptoms would be fever, muscle aches, cough, breathing problems, shock, and the person may also die. Okay, it was a serious infection. So for this also Louis Pasteur was the one who discovered vaccine. Okay, and then rabies. Pasteur's work on rabies culminated in the development of vaccine for the disease, which he tested successfully on a young boy named Joseph Mister after he had been bitten by a rabid dog. This was a landmark achievement as rabies was a fatal disease at the time. So yes, he also discovered vaccine for rabies. Okay, so rabies was actually a fatal viral disease that affects the central nervous system. Okay, and primarily transmitted through saliva of the infected animal. So when a person is infected with rabies, no, so he'll have symptoms like fever, headache, pain or tingling at the bite site, weakness and hydrophobia, which is nothing but fear of water. So if left untreated after the symptoms appear, rabies is almost always fatal. Okay, so and he will discover a vaccine and he will first inject that to a young boy whose name was Joseph Mister. So he will be bitten by a rabid dog and he will successfully inject to him, so where he will obtain immunity from the disease. Okay, so these were some of the achievements of Louis Pasteur.